Hello everybody, my name is Preston Miller, and welcome to this presentation on the overview of the four fundamental forces that exist in our world. To begin, I want to discuss what force is. Force is any interaction that, when unopposed, will change the motion of an object. Force can also be described intuitively as a push or a pull. Newton defined force as anything that caused an object to accelerate, and many of us are familiar with the simple equation F equals ma, or force equals mass times acceleration. There are a few categories of forces which are important to understand. The first are contact forces. Contact forces occur when two interacting objects are perceived to be physically contacting each other. A few basic examples of contact forces are the friction force, tension force, and normal force. Another category of force is at-a-distance forces. At-a-distance forces occur even when two objects are not physically touching, yet are able to exert a push or a pull on one another despite their separation. A few examples of at-a-distance forces are within our solar system. Although there's great distances between each planet, that force allows them to continue to stay in orbit. Along with jumping up and down, although our feet are not on the ground, we still feel a force pulling us back down towards the earth. All of the forces we feel on a day-to-day basis can be categorized into four main forces. These are gravity, the weak force, electromagnetism, and the strong force. Each of these forces have something that are called force carriers. Force carriers basically are particles that give rise to forces between other particles. We'll discuss this more as the presentation goes on. The first fundamental force which I would like to discuss is gravity. Gravity is the force that attracts a body towards the center of the earth or toward any other physical body having mass. Surprisingly, gravity is the weakest of the four fundamental forces, which could be surprising because it's what keeps our solar system in orbit. Gravity's force carriers are called gravitons. Although gravitons are not yet observed, we know they exist because we are able to see gravitational force on a day-to-day basis. Newton discovered that gravitational force is universal, but it does depend on the masses of the objects and the distances between them. The equation that he came up with was F equals G times m1 m2 over r squared. F being force, G being the universal gravitational constant, m1 and m2 being the masses of the distinct objects, and r being the distance between those objects. Something important to understand for these next forces that we will talk about are quarks. Quarks are one of the fundamental parts of all matter. They are particles that combine to form hadrons, some of which are protons and neutrons, and that's what we will refer to mostly throughout this presentation. Quarks can exist in three color charges. Those are red, blue, and green. Each color has to exist in the same quark in order to cancel out each other and keep the nuclei together. These colors are important for the strong force, and we'll discuss that later on in the presentation. There are also 6 types of quarks known as flavors. These are up, down, strange, charm, bottom, and top. These flavors can change from one to another through the weak force, which will be seen a little bit later in the slides. As you can see from this image, protons and neutrons each contain 3 quarks. Protons have 2 up and 1 down quark, whereas neutrons have 2 down and 1 up. Let's discuss the weak force. The weak force is an interaction at short distances between subatomic particles mediated by the weak force. This weak force is also known as weak nuclear force. This force is responsible for radioactive decay of atoms and serves an essential role in nuclear fission. Radioactive decay is the process by which an unstable atomic nucleus loses energy by radiation. The weak interaction is 10 to the 25th times stronger than gravity. The force carriers that mediate the weak force are called bosons. There are W bosons and Z bosons. W bosons have a positive or negative charge, and Z bosons are neutral particles. From this example, I will discuss how neutrons are changed to a proton and how this decay happens. A particle called a neutrino, which is basically a neutral particle, contains a positively charged W boson. The weak force is what causes this W boson to go to the neutron and interact with one of the down quarks. This W plus boson causes the down quark to become an up quark and changes the particle to a proton. Since the neutrino lost its positive charge, it becomes an electron, and we see that now the proton has 2 up quarks and 1 down. The weak force is what caused this change to occur. This transition from a neutron to a proton changes the atom to an entirely new element, which is called decay. This example shows that carbon-14 contains 6 protons and 6 neutrons, but when it undergoes the weak force, it becomes nitrogen because it now has 7 protons and 7 neutrons. The next fundamental force we will discuss is electromagnetic force. Electromagnetic force is 10 to the 36 times stronger than gravity. It comes in 2 different forms, but they look exactly the same to us. The force carrier for electromagnetism is the photon. We can see from the name electromagnetic that it involves charges, the electro side. Positive charges that come together repel each other, whereas positive and negative charges attract. This is also true for magnets, which have a positive end and a negative end, known as the north and south pole. Electrostatic force is created by positive and negative charges. It's important to note that the greater the charge, the greater the force, and the greater the distance between the charges, the smaller the force. This is also known as Coulomb's law. This is what allows protons to keep electrons from leaving the nucleus. A way to visualize the electrostatic force is something that we have often seen. Using a balloon and a wool sweater, as you rub a balloon across a wool sweater, the balloon gains electrons and the sweater gains protons. These charges cause the balloon to stick to the sweater. Magnets also have a positive end and a negative end. These ends act in similar way to charges. Positive ends repel, and positive and negative ends attract. An electric current can be created through changes in magnetic fields, hence the name electromagnetic force. We'll now discuss the last fundamental force, the strong force. The strong force is 10 to the 38 times stronger than gravity. This force holds most ordinary matter together. It also binds neutrons and protons to create atomic nuclei. As we discussed earlier, the force carrier of the strong force is the gluon. Gluons carry the color charge in strong force. Gluons basically create a rubber band effect which keeps the various quarks together and stable. As we know, red, blue, and green quarks have to coexist at the same time in a particle. 2 blue and 1 green, or 2 blue and 1 red, cannot exist, and it will not allow the particle to work correctly. But gluons keep the particles changing colors and at the same time creates a rubber band effect, stabilizing the protons and allowing them to stay together in the nucleus even when they repel each other. The gluons are what create the nuclear force. Nuclear force is strongly repulsive at very small distances, which keeps the protons and neutrons away from each other for a bit. Nuclear force is strongly attractive at slightly larger distances. This strong force is what keeps protons apart but bound together at the same time. As you can see in this visual, electron repulsion of protons strains the nucleus, but the residual strong nuclear force holds the nucleus together. In conclusion, the 4 fundamental forces of physics are gravity, the weak force, electromagnetism, and the strong force. Thanks for watching.